So I'd like to show you three of my favorite Stratasys 3D printing materials, two from the world of PolyJet 3D printing and one from the world of FDM 3D printing. So let's start with the PolyJet. First up is the VeraClear material. The VeraClear material is a clear transparent 3D printing material produced on the PolyJet 3D printers. The Stratasys VeraClear material features excellent dimensional stability for general prototyping purposes, and its aesthetic qualities make it particularly suitable for fit and form prototyping when you really need to produce an excellent looking model like this iPad stand right here. That's one example. Another example that I have up is this 3D printed chair, this folding chair. And of course the VeraClear material, because of its transparency, is excellent for when you need to produce a nice polished finish to the material. An example of that here is this castle, which features a very nice gloss finish to the surface. And of course you've got details here that go down to below 1 millimeter in thickness, such as these turrets, if you can see these turrets just here. Another nice example is this 3D printed wheel, where you can see the details, this honeycomb structure inside the wheel. A very nice example there. And of course, if you have a Connex multi-material 3D printing system, you can achieve results such as this. You can mix the VeraClear material with a number of other materials in the same 3D printing process. The second PolyJet 3D printing material I'd like to show you is the digital ABS material, which is this green material you may already be familiar with. Now, the digital ABS material is great for fit, form, and also particularly functional prototyping, and it also has some very special applications that we'll show you just shortly. So the digital ABS material is a composite material, what we call a digital material, that is fabricated on the Connex system exclusively, and it's made by combining the RGD 515 with the RGD 535 material within the 3D printing process. And the result of combining these two materials creates a material that is very tough, combined with the traditional excellent surface quality that we get from the PolyJet 3D printing systems. The material has an impact resistance of between 65 and 80 joules per meter. That's a notched ISOD impact resistance, and a heat deflection temperature of between 58 and 68 degrees C, but this can be raised to 95 degrees C when you put the material in a programmable oven. Now, I have some nice examples to show you here today. We have this is an indicator from the automotive sector, and you can see the digital ABS material has been used here, and it's used because they required a prototype that will be able to constantly flick and click without producing wear and tear over time. So that is a nice example from the automotive sector. Another example from the consumer goods sector, this is a respirator, or defense sector if you like. This is a respirator where the digital ABS material has been used at the points where it is required to hold the fasteners, the elastic fasteners, in place. So this is required here at these small points here, which you can see. These are quite small and require high toughness. Another example which demonstrates the flex and bending of this material is this nice little catapult that we've designed for you. And we can actually have a go and see how far we can release this catapult. It's a good result. So the digital ABS material demonstrates excellent flexing and bending. The material is excellent also for snap fit parts and other industries that require a mix of toughness and high surface quality. So thanks to its high toughness and temperature resistance, and also the great surface quality that you get from the PolyJet 3D printing process, the digital ABS material can be used to produce molding tools for short runs of injection molding. And here's an example of some molding tools that I've produced for us. And in this case, you can see that we have a screw thread printed in here. And in this particular mold tool, I produce a number of examples of real plastics that we've injected into this particular mold. Here's an example of acetyl. Acetyl can be injected at 200 degrees C into this mold, and you can produce a number of iterations. The acetyl is a very good material for when you need automotive or electrical parts with a good snap to the material. Going up in scale, we have glass reinforced nylon. Now this material is injected into the mold at 285 degrees C. And due to the fact that you've impregnated the nylon with 20% glass, you actually need to have about 200 bars of pressure built up into this mold in order to produce this end part the way it needs to be produced. Substituting for nylon, we also have glass reinforced polypropylene. This is also 20% reinforced with glass, and this is used where the nylon is sometimes too expensive, and this application is used where you need a cheaper alternative to the nylon. So that's the injection molding plates. Another example, just to finish off, just to demonstrate the fine detail quality of the digital ABS material. This is an end part produced in regular ABS at 220 degrees C, and I'm just using this to show you, demonstrate to you the actual fine details and the thin walls that you can achieve using the digital ABS mold plates. Another very useful manufacturing application for the digital ABS material is in blow molding, and I have a very nice example for you here. These are mold tools printed in the digital ABS material, and inside we have injection molded PET material that is then blow molded inside the mold at 10 or 20 bars to produce this very nice bottle. We have some other examples here where you see more detail has been included in the molding process. Another interesting thing to note is that when you're 3D printing the mold plates to produce a short run series of injection molded bottles, this usually occurs quite late in the product development process. And you can actually help that process along by producing the actual shape of the bottle using the 3D printing material itself. So whereas this is an end part, this is an actual prototype printed in the Vero Clear material that we showed you earlier. Here's another example of a blow molding tool. This is used for extrusion blow molding. The material here is high density polyethylene, which is blow molded and introduced at 180 degrees C into the tool. So another nice example here, we have injection blow molding, extrusion blow molding, and both of these can be achieved very nicely using the digital ABS material. So let's put aside the polyjet materials for one moment and have a look at one of my favorite FDM materials. The Ultem 9085 material features an ISOD notched impact of 106 joules per meter and also a heat deflection temperature of 153 degrees C. So this material is really ideal for producing high-end prototypes that can be functionally tested, as well as special parts that can be used in the actual production process, whether it's aerospace, automotive or defense. An excellent example of the Ultem 9085 material in action is this functional hairdryer that I've actually obtained for us today. This hairdryer has been assembled using the Ultem 9085 material, and inside you can see all of the actual real parts, the electric cables, and of course the screws that have enabled this part to be assembled, and it enables it to snap fit together and move. And of course, thanks to the high heat and chemical resistance of the material, this hairdryer can actually be used functionally.